Hello and welcome to this solution video. If you like this, please like it by giving it a thumbs up, share with your friends and subscribe to Math United. Let's start with question number 1. Two particles P and Q of masses 0.2 kg and 0.5 kg respectively are at rest on a smooth horizontal plane. So let's say this is horizontal plane. This is particle A, this is particle B. Rather, they're saying P and Q. So we'll say P and Q. 0.2 kg is the mass of this one, 0.5 respectively. So here. A particle P is projected with a speed of 6 meters per second directly towards Q. Okay, 6 meters per second. After P and Q collide, P moves with a speed of 1 meter per second. So there are two possibilities that this P after colliding with Q, Q moves this way and P also moves this way. Okay, that's one possibility. Another possibility is that Q will move this way. Q cannot move this way because it was stationary, right? It is at rest. So, second possibility is that the P collides with Q and goes in this direction. That's why they're saying find the two possible speeds of Q after the collision. So we'll say case 1 when P keeps on moving in same direction. Okay, and second will be case 2. P rebounds. So since this is a smooth surface and the collision will be perfect, the momentum will be conserved, and for conservation of momentum we have this formula which is m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So m1, the mass of P is 0.2, so we'll write 0.2 multiplied by the speed it was going with 6 meters per second in this direction initially before collision. This one is before collision, this one is after collision. Okay, so second one is the other mass 0.5 kg is at rest, so no speed. Then the first mass P goes with 1 meter per second in the same direction it was going, so the 1 will remain 1 because 6 was positive, this direction is positive, so we will keep this one as also positive because it is going in the same direction. Plus, what is the speed of Q? We don't know, and that's what we want to find, which is V2 for Q. So this becomes 1.2, this is 0, so we'll ignore it. This is 0.2 times 1, 0.2, but if I bring it to the left side, minus 0.2 equal to 0.5 V2. So 1 equal to 0.5 V2, and V2 will be 1 divided by 0.5, which will be 2 meters per second in the same direction, which is the positive direction, this direction. Second possibility, P rebounds. So the whole equation remains same except for this one, which we know will be in this direction. Now this will become minus 1. So I'll count this as minus 1 now. So 0.2 times 6 will still remain 1.2. 0 will remain 0. And 0.2 times 1 will be minus 0.2. This time 1 will not be 1, it will be minus 1. And then 0.5 V2. So 1.2 plus 0.2 equal to 0.5 V2, 1.4. equal to 0.5 V2, and V2 will be 1.4 over 0.5, and as expected V2 is also positive. So in both cases it will go in the same direction. Q will move in this direction in both cases, once with 2 meter per second, the second time on second option is 2.8 meters per second. Masses cause this rebounding and going in the same direction. Question 2. A particle of mass 0.2 kg is attached to one end of a light inextensible string, this one. The other end is attached to the fixed point on the vertical wall and making an angle of 30 degrees, held equilibrium by a force of x Newton perpendicular to the string. Okay. Find the tension in the string and value of x. Two of the components we have to find out. First, let me draw its components. So one line I will draw vertical, and the second line will be horizontal from the mass. So here it is. Now I'll have to write the components. So the component of x and t, let's say this is t, the tension in the string, that's what they're saying. Find the tension in the string. So this is t. If this is 30 degrees, this angle will also be 30 because it is alternate angle to this angle. So the component of t in this direction will be t cos 30 degrees, because any component that is making the angle with the main force is cos component all the time. The one on the opposite side of that force will be the sine component. So it will be t sine 30. Similarly for x, we don't know the angle yet, but we know this is 30. That means this will be 60, and remaining this will be 30 again, because this is also 90 degrees. So let me write this as 30, which will help me to find the component of x. And again, this is the component which is making this 30 angle, so it will be x cos 30. And the one which on the opposite side of the force will be x sine 30 degrees. So there are two forces up and this. So two tilted forces, we have broken them into components. Now we will first compare the V, right? Which one is the, yes, let's say vertical components. So in vertical component we have this weight which is 2 newtons, yeah, 0.2 multiplied by 10. 2 newton is the weight of this mass. So 2 newtons is equal to t cos 30 plus x sine 30. So if we can write the values of these two, 2 will be equal to t cos 30 is square root 3 over 2, and sine 30 is half, so x over 2. Alright, and we can, okay, multiply the whole equation by 2 so that this 2 is taken care of. So 2 times 2 is 4, equal to this 2 and this 2 will cancel out while multiplying, so square root 3t, and this 2 and this 2 will also cancel out. This becomes our equation number 1. Let's talk about horizontal components. So horizontal component, we have x cos 30 equal to t sine 30. There is no other component visible. So cos 30 is square root 3 again, square root 3 over 2 x is equal to 1 over 2 t. Sine 30 is 1 over 2. 2 and 2 cancel. This gives us t is equal to square root 3x, equation number 2. Now we can substitute equation number 2 in 1. So 4 remains 4, square root 3. Now t is square root 3x and x is x. So square root 3 times square root 3 is perfect 3. So 4 equal to 3x plus x, 4 equal to 4x. So this gives us x equal to 1 Newton. 4 divided by 4, 1. Okay, and now t we have to find out. T is square root 3 times 1 because x is 1 now. So t is square root 3 newtons. If you want to write in decimal, is it allowed? Yeah, they have not said it to be written in exact form. So you can leave your answer like this or write this in decimal 1.732. Question 3. A car travels along a straight road with a constant acceleration. This is important. With a meters per second square, where a is positive, it's accelerating. The car passes through A, B, and C in that order. So let's see if this is horizontal space. This is A, this is C, and B is somewhere in between. Let's read the whole thing. The speed of the car at A is u meters per second in the direction of AB. So B is somewhere here. The distance BC is twice the distance of AB. So that means AB is smaller and BC is twice of this. So let's call it this x and let's call this as 2x. From B to C, 2x, twice. The car takes 8 seconds to travel from A to B. So time taken from A to B is 8 seconds and time taken from B to C, 10 seconds to travel from B to C. So time is 10 seconds here. Find u in terms of A. Okay, so we have this variable, and A and u. Okay, so let's do what? Let's write an equation for distance traveled. So formula is S equal to ut plus half at squared. This is the formula for the displacement, and we'll talk about this one first. Displacement from A to B is x equal to u is u, t is given 8 seconds from here to here, plus half, acceleration is a, and 8 square, time is 8 again. So it comes out to be x equal to 8u plus half 64a. Yeah, 8 square is 64. So this cancels 2, they are multiplying and dividing, so this will cancel, this will become 32a. Alright, so x is 8u plus 32a. But we don't want x and we want u in terms of a. U and a will stay, but x has to go. So this will go with the help of second phase, which is from B to C. Here the s displacement is 2x equal to u is u, not u, because here it is starting from here, so u is not u here, it becomes v of this phase. So let's find this also somewhere. Let me do it here. V equal to u plus at. This is another kinematic equation and we want to find this v in terms of u and at. So it will be v equal to u. U is u, a is a, but time is 8 seconds. So v becomes u plus 8a. So we don't want so many variables, that's why I'm doing this. So in place of 8u, sorry, not 8u, or this u, in place of this u I will use v because that is u for the initial velocity for this phase from B to C. So this v which was v for final velocity for A to B becomes initial velocity for B to C. So in place of this u, we will write now u plus 8a. And now t is there, t is 10 seconds in second phase. This is from B to C. This one is from A to B. Okay. Plus half, A is A and T is T, 10 seconds. So let's do what? Let's substitute this x also. Let's get rid of it. In place of 2x, in x we'll write 8u plus 32a. 8u plus 32a, because it's the same x we are talking about, right? Equal to 10 times u, 10u plus 80a. Yes, plus half a times 100. This 2 and this will also cancel out, 50. So 16u plus 64a equal to 10u plus 80a plus 50a. So let's collect u on one side, a on one side, because we want u in terms of a. So 16u stays here, but 10u comes to the left, so changes its signs to negative. This is a, this is a, 130a. Yeah, 80 plus 50. This 64 will also come to the right side and change its sign, 64a. 6u equal to 66a. And now it becomes easy. U equal to 66 over 6a. U is equal to 11a. This is our u in terms of a. Okay, done. Find the speed of car at C in terms of a. So acceleration has not changed throughout. So we can take u as u now. So we can use this formula, v equal to u plus at. V equal to u plus at. So v is v, because now I'm taking the whole stretch of from A to C. U is u at the starting, u was u, so u plus a throughout is a. So we'll not just touch this. So it comes out to be how much? T. Total from here to here was 16, 6 plus 10. Yeah? No, 8 plus 10, 18. So it will be 18. We want a in terms of final speed in terms of a. All right. So v is equal to, we don't want u. So u is 11a. So we'll write 11a now. Plus 18a. So v is 29a in terms of a. Got it. Final velocity at C is 29a. Question 4. A particle travels in a straight line. The velocity of the particle at time t seconds after leaving the point O is this, a quadratic. Okay. The distance traveled by the particle, by the particle in the first 2 seconds of its motion is 6 meters. You may assume that v is positive in the first 2 seconds. Okay. So this distance doesn't matter. Since they have confirmed it is positive, that means if we draw a VT diagram, our graph will be either going down. If there is a turning point, it will stay up, or if it is going up, it will be going up, and in 2 seconds it stays in positive direction. So there is no direction change, only the speed changes, but direction remains positive in both cases. So we don't need to worry about the word distance in this case. Okay, find the value of k. So it's a quadratic, so we'll have to integrate this to find displacement, which is also distance in this case. So integration of velocity with respect to time will be integration of k, let's keep constant outside, t square, then minus dt minus 4 t dt plus 3 dt. Okay, so this integration of velocity gives us displacement, let's call it as kt cube over 3, then minus 4 t square over 2 plus 3t plus c. And we want in first 2 seconds, that means from 0 to 2. So this we have to find from 0 to 2, and there is no direction change, so we just substitute. So s is equal to k 2 cube over 3 minus, this can cancel, 2t square, so rather we have to substitute 2 here, my plus 3 times 2 plus c minus, we'll substitute in place of t we'll put 0 also, so that is not going to make any difference because 0 cube will be 0, so this is gone. 0 square will also be 0, gone, plus 3 times 0 will also be 0, gone, and this c will cancel out with this c because there is a negative in between, so gone. So we have to just find this one, 8 over 3k minus 8 plus 6, and they said it is equal to 6 meters. The distance in first 2 seconds is 6 meters. So in place of s I'm writing 6. This 6 and this 6 can cancel, and let me bring 8 to the other side. So 8k over 3 equal to 8. Cross multiply, this will give us k equal to 8 times 3 over 8. Cancel also, so k is equal to 3. They said find the value of k, we just found the value of k. The second part, also find the value of minimum velocity of the particle. You do not need to show that it's minimum. Okay, so minimum velocity, now it becomes 3t square minus 4t plus 3. 3t square minus 4t plus 3, this was v, right? And if I differentiate this, it will become dv over dt, and we'll differentiate this one, which will be acceleration. And acceleration will be minimum if it is, this is the case they're saying, right? That means here the acceleration is minimum because the rate of changing velocity is 0 and it is changing its direction here, so dv over dt will have a horizontal gradient which is 0. So we have to make it equal to 0 and we'll get time because of this. So it becomes how much? 6t minus 4, and this is 0, differentiation of 3 will be equal to 0. So 6t equal to 4, t is equal to 4 over 6, which is 2 over 3. Yeah, so this after 2/3 of second it reaches at minimum velocity, and we don't have to show that this is minimum because we're getting just one option, one answer, and they're confirming it is minimum. So we have to find velocity. Now show the velocity, we have to find minimum velocity. So velocity equation was this, 3t square, 3t square, which is 2 over 3 square now, minus 4 times 2 over 3 and plus 3. this velocity at time 2/3. So 4 over 9, 3 times 4 over 9 minus 8 over 3, this also cancels, this 3 and this also cancels, plus 3. So 4 over 3 minus 8 over 3 will be minus 4 over 3 plus 3, and if I simplify this or make it one number, it will be 9 minus 4, 5 over 3 meters per second. This is the minimum velocity it has. You can convert it to, are you saying exact value? You can convert it to 3 second figures in decimals, so which will be how much? 1.67 meters per second. Okay, question number 5. A van of mass 4,500 kg is towing a trailer of mass 750 kg down a straight hill inclined at theta degrees. So let's say this is downhill and this is a van and this is a trailer. Okay, the mass of van is 4,500 kg. That means its weight will be 45,000 newtons, and the weight of trailer will be 77,500. all right, the angle is theta here. The van and the trailer are connected by a light rigid tow bar which is parallel to the road. Okay, there are constant resistances of 2,500 on the van, so 2,500 on the van, so this way 2,500 newtons, and on trailer 300 newtons. Okay, it is given that the tension in the tow bar is 450. It will be pulling it this way and obstructing it this way. Okay, 450 newtons. Find the acceleration of the trailer and the driving force of the engine. Acceleration of the trailer, so where do we have maximum things possible? A is not known to us, applied force is also not known to us. This will be applied force here, which they are asking driving force, which will be applied force here, but there are natural forces which are driving it down. Yeah, so that force on the van, this one will be 45,000 sine theta. On the trailer also it will be 7,500, the sine component of the weights basically 7,500 sine theta. These will naturally bring them down. Additionally, the applied force by the engine of the van will be bringing them down. Okay, and done everything. So we have to find acceleration first, right? Let's focus on acceleration, where most of the things are known is this part. If you see this trailer part, we know almost everything except the acceleration. So let's focus on this one. So what are the forces downwards? Okay, it is 450 Newton tension plus 7,500 sine theta is also downwards. In place of sine theta, they have given sine theta's value. So let me write sine theta's value 0.05, which is here. All right, 300 is backwards. Okay, this is done, this is done, this is done, and this will be equal to mass times acceleration, which is net force, right? The acceleration will be caused by these forces. So I'm focusing only on the trailer. So I'll have to use my calculator to find 7,500. Let me do it. 7,500 multiplied by 0.05. Okay, it is 375. So 450 plus 375 minus 300, and since we are focusing only on the trailer, its mass is 750, so in place of mass we'll write 750 A. So 450 plus 370 will be how much? 825 minus 300, 525 equal to 750 A. So A is 525 over 750, which will be 0.7 meters per second square. So the first part is done. Find the acceleration of the trailer. Okay, so this is a trailer only. Okay, though it will be, because they are connected, it will be the acceleration of both. Okay, now we have to find the applied force. So let's include applied force and write the whole system. So what are positive forces? We'll use the same formula again. What are the positive forces which are driving it down? 40,000, 45,000 sine theta, which is 0.05. This is one positive force. Now tension is part of the system, so I would ignore 450 because I'm taking the whole system now. This is applied force. Okay, and this 7500 sine theta, which was 525, no, 375. So I have taken up this, I've taken this, I've taken applied force, and now the opposite ones. 2500 minus 2500, 300 is also minus, and that's it, equal to MA. M this time, because we are taking the whole system, we'll add both masses. A. Sorry, A is also known to us now. 0.7. So F applied is the only one which is unknown, and that's what they're asking us. So we'll keep it here. And 2500, 300, so 2800 goes to the other side, become positive, but 375 will become negative. So 45 times 5 is 225, so minus, right? Yes, 2250, and this will be 5250 plus 5250 times 0.7. So this is taken care of, this is taken care of, this is taken care of, everything is taken care of. Okay, so applied force by the engine will be, let me put this everything in your calculator and I'll get the answer. What I'm getting here is 3850 newtons. That's the applied force. Okay, let's move on to the next part. On another occasion, the van and the trailer ascend a straight hill. Okay, so they ascend this time. So van will be in front, trailer will be following at an angle to the horizontal sine theta is 0.09 this time. So this is angle A, and sine A is 0.09. Okay, the driving force of the van's engine is now 9100 newtons. So applied force is given to us, 9100 newtons. Okay, and the speed of the van at the bottom of the hill is 20 meters per second. Here, the resistance of the motion are unchanged, though still it will be 2500 here, 300 here, but there will be again two no, it was 4500, right? 45000 sine alpha or sine A in this case. Alright, and this will be 7500 sine A. These two will also add up to applied, the resistance force. Yeah, because it is going up, so these will obstruct now. Alright, find the acceleration of the van and the tension in the tow bar. So whichever is van, so tow bar is here. Let's take the whole system again. So positive force is 9100, and that is the only one. Everything else is against it. 2500, so I will say minus. Let's add all of them. 2500. 300 is also against. This is also against, which was this time, no, this time is different. So it will be plus 7500 sine, in place of sine alpha, we'll write 0.09. And 45000 times 0.09. This whole thing is equal to MA. Mass of the two was 5250 A. So everything is known to us. We can use this in our calculators. So it will be 5250 A equal to 9100 minus 7525. So 5250 A is equal to 1575. Now acceleration will be 1575 over 520, which is 0.3 meters per second square. Got the acceleration of the system or van is the same thing. Now we need to find the tension in the tow bar. Yeah, for tension, this tension, yeah, is going up. So tension is the one. If I focus only on the trailer, tension is the one which is bringing it up. So the effect of all these forces will be involved in tension, so don't worry about the rest part. So tension minus, there are forces 300 backwards, and there is force, this one also, 7500 times 0.09 will be equal to the net force, which is mass times acceleration. Mass for the trailer is 750 kilograms, and its acceleration we just got 0.3. So now tension is the only one which is unknown, so we will keep it here and everything will go to this side. So 300 will come here and become positive, plus 9 times 750 will be 675, no, 675. Then plus, we already have this one, so it will be 225. Tension will be 900, 1200 Newton. We got the tension of in the tow bar. Both the things done, acceleration as well as tension. Second part is find the speed of the van when it has traveled distance of 375 meters up the hill. Okay, so we know U, we have to find V. What is the V there? So we can say that V square is equal to U square plus 2AS. We know everything. Also V will be square root of U square. Now U is 20 plus 2 times, what is the acceleration? We got it, 0.3. S they have given 375 So V comes out to be 400 plus 0.6 times this 225. So it becomes 625, square root of that will be 25 meters per second. We got the speed of the van or the whole system 375 up the hill. This is the speed. Alright, question number 6. A cyclist is traveling along a straight horizontal road. The total mass of the cyclist and her bicycle is 80 kilograms. So mass is 80 kilograms. There is a constant resistance force of magnitude. So resistive force is there 32 newtons. At an instant when she's traveling at 7 meters per second, her acceleration is 0.1 meters per second square. Find the power output of the cyclist. Okay, so power at any instant is whatever is the applied force by that force whose power we are finding, in this case the cyclist, multiplied by the velocity at which it is traveling. So we know the velocity, which is 7 meters per second at that instant, but we don't know what is applied force. So we'll use the same formula we used in previous question rather. MA equal to applied force minus resistive force. Okay, M mass is 80 kilograms. Acceleration at that moment is 0.1. Applied force, we want to find out how much force she is applying minus resistive force is given 32. So this is 8. This minus 32 will come here and becomes plus 32. Will be the applied force 40 newtons. That we have to apply here. So power will be 40 newtons multiplied by the velocity she is having 7 meters per second, which is 280 watt. Okay, find the steady speed that the cyclist can maintain if her power output and the resistance are both unchanged. So now the steady speed she has to keep if her resistance remains the same. So when the steady speed is there, that means there is no acceleration. If there is no acceleration, this equation, which was ma equal to applied, becomes 0 because there is no acceleration. Acceleration is 0. So applied minus resistive force. So resistive force and applied force, they become equal, and they are saying that the resistive force remains 32 newtons. So in this case her applied force also becomes 32 newtons. So fine, and the power output is also the same. Her power output is also same, which was 280 watts. So power is equal to applied force times velocity. This is what we just used in previous part. So power is 280 unchanged. Applied force is 32. They are asking what will be the speed in this case. So it will be, velocity will be 280 divided by 32, which is 8.75 meters per second. Okay, so the cyclist later descends a straight hill of length 32.2 meters. Total distance is 32.2. Okay, incline an angle of sine inverse 1 over 20. So let's call it theta. So sine theta is 1 over 20 to the horizontal. Her power output is now 120 watts. and the resistance force now has variable magnitude such that the work done against the force in descending the hill is 1128 joules. So work done against resistance is 1128 joules. The time taken to descend the hill is 4 seconds. Given that the speed of the cyclist at the top of the hill is 7.5 meters per second, find her speed at the bottom. So let's use energy formula for this, which says that the work done by the applied force, which is the cyclist this time, will be the sum of the work done against the resistive force plus change in kinetic energy plus change in potential energy. Okay, so let's see what is applied force, work done against applied force. We can see that the power is applied force multiplied by the speed at that time, right? That was the one we used earlier, but here we will use the one where how much work is done in how much time. This is another formula for power. Time is 4 seconds and power is 120 watts. So we can find the work done by applied force in this case. Which comes out to be cross multiply work done by applied force is 480 joules. So it comes out to be 480. Work done against resistance is 1128. How come? Is it possible that the work done against resistance is more than this? Yes, it's possible because it's descending, going down. So its own energy, means the natural energy or the potential energy, will help. So don't worry about that. Plus delta Ke, the change in kinetic energy is half m. M is 80 for both. V square, which is the final velocity, and they're asking final velocity, right? Find her speed at the bottom of the hill. What is the speed here? Minus initial velocity, which is given 7.5 square. This is change in kinetic energy plus change in potential energy. Since it is coming down, the cyclist is coming down, the potential energy reduction will not be actually, it is reducing the height. So it will be negative. So don't worry, it will get it negative. The formula for change in potential energy is m, which is 80, g, which is fixed 10, and change in height. Height earlier was this, right? And finally it is 0. So height, final height, which is 0, minus initial height, and that will give it a negative value because initial height is higher. Let's find what is initial height. So we know this is 32.2 meters. This is theta, this is h, so we can use by sine theta. Sine theta is equal to opposite over hypotenuse. So sine theta is given to us 1 over 20. Sine theta is 1 over 20. So 1 over 20 times 32.2 cross multiply equal to h. So let's see how much we get. 1.61. Okay, if I divide 32.2 divided by 20, it will be 1.61 meters. So it will be 1.61 meters here. V is the only unknown parameter, and that we will find out now. Okay, so I'll keep it here and bring this to the other side. So 480 remains 480, then minus 800, this one 80 times 10, and times minus 1.61. Okay, all right, this is done, and minus 1128 Okay, equal to 2 and 80 may cancel, so 40 will be here. V square minus 7.5 square. Rather, I can write 7.5 square also, it will be 56.25. Okay, everything taken care of. So let's evaluate them one now. So 800 times 1.61. So it comes out to be 640 equal to 40 times V square minus 56.25. We divide both sides by 40 to get rid of this 40. Cross multiply basically. So 16 equal to V square minus 56.25. Let's bring 56 also to the other side. So what will we get? V square equal to 16 plus 56.25. So V square equal to 72.25, and square root both sides. It has to be positive answer only, so 8.5 meters per second. So it started at 7.5 meter per second from top. Here at the end it is 8.5 meters per second. Question 7. The diagram shows a track ABCD which lies in a vertical plane. The section AB is straight line inclined at 30 degrees with the horizontal and smooth. So this one is smooth. Okay, the section BC horizontal straight line and is rough. CD is a straight line at an angle of 30 degrees again and rough. And ABCD are 2 meters each. So this is 2 meters, this is 2 meters, this is 2 meters. Okay. A particle is released from rest at A here, goes down. The coefficient of friction between the particle in both BC and CD is mu. There is no change in the speed of the particle when it passes through B and C. Given that mu is 0.1, find the distance which the particle has moved up the section CD when its speed is 1 meter per second. So that means at C there will be some speed, obviously more than 1 meter per second. It goes up and we are not waiting till it comes to rest. We will see wherever the speed is 1 meter per second, what is the distance? That's what they're asking. So first, since this is smooth, it will be easy for us to find what will be the speed at B. So speed at B equal to V, let's say V. So we can say that V is equal to U plus, no, so we can say that V square is equal to U square plus 2AS. V square will be equal to U. It is being released from rest, that means it is 0 square. 2 times acceleration is not known to us, but distance is known to us, which is 2 meters. Right? Now what about acceleration? When something is released, there's no force which is pushing it. So our general formula for forces is that the F net, which is ma, is equal to the applied force minus resistive force. So mass is mass unknown. They have not given mass anywhere, so we'll say that the acceleration is acceleration equal to applied force. There's nothing is pushing it down, but it is coming down by its own weight, right? What is the weight here in this direction? It will be 10 times whatever is the mass, right? So the force which is forcing is down, it is 10 m sine 30 degrees, because the angle here is 30 degrees. So it will be 10 m sine 30 degrees. M and M can cancel both sides if we divide both sides by M. So A comes out to be 10 and sine 30 is half. So it is 5 meters per second square. Mass was not important in this case. So here we'll write 5. V square is equal to 10 times 2, 20. And V comes out to be square root 20. So we got the speed here, which is square root 20 meters per second. Okay. Now we have to find what is the acceleration in this direction. And for that also we will use the same formula. M unknown, acceleration unknown is equal to applied force. There is no force which is pushing it down now, because earlier it was coming down because of its weight. But now there is no applied force, so 0. Minus. There is resistive force in this one. Why? There's a friction, it's rough. And that resistive force is mu r frictional force. Okay. So that's what we will find out now. What is it? Minus mu. Mu is given 0.1. And R is the contact force, and contact force is whatever is its weight, same will be the contact force, because it is not flying off or sinking in, so they will be equal, which is 10 m. Whatever is the weight is the contact force, right? So m and m cancel again. Acceleration comes out to be minus 1 meters per second square. So this was from A to B. Now B to C, we'll use the same formula, V square, and this time the U will be square root 20 because it's starting from B now. So square root 20 square, and then we have 2as plus 2, A is a negative 1 and S is again 2 meters. So V square equal to 20, and 2 times 2 is 4. 16. So V will be square root 16 for 4 meters per second. So here the speed is 4 meters per second. Now third phase, when it goes up, right? Again there is no applied force anymore. Like this part, there is no applied force, but there will be the same force, this one, which will be resisting it now, right? So MA equal to no applied force minus mu r is also there because it is rough, so mu r will be there, and there will be a force which is resisting it because of the weight, which is 10 m sine 30, and 10 m sine 30 we got it earlier. 10 m sine 30 was 5. Yeah, 10 sine 30 will be 5 m. M will remain, right? We cancel m here, but will not cancel m here. Now MA equal to minus 0.1, and this contact force will be perpendicular. Normal contact force is normal to the surface, which will be equal to this particular force, which is the cos component of the weight. The weight will be down this way, 10 m. This will be 10 m cos theta, and cos theta is 30. So 30 cos 30. Same here, it will be the same, again the same logic. It is not flying off or sinking, so this will be 10 m cos 30 degrees, which is normal contact force. That we will use in place of R. So 10 m cos 30 value is square root 3 over 2. So let me write square root 3 over 2, and 2 can cancel with this. So minus 5m. Okay, let's make some space here. So MA is equal to negative 0.5 square root 3 m minus 5m, right? M gone, M gone, M gone. Mass is not important, so acceleration is negative square root negative 0.5 square root 3 minus m, which is minus 5.87 meters per second square. We got acceleration. So now we can go to the third part of this, which is from C to D. So V we want 1 meter per second. They said find the distance it has traveled of CD when its speed is 1 meter per second. So 1 is our target velocity, will be equal to u, and u is square root, sorry, it is 4. At the C it is 4, so 4 square plus 2 times acceleration is minus 5.87 and distance we do not know, right? So 1 square is 1 minus 4 square is 16. It became 16, okay, when 4 square went there, and this will multiply with this, so it will be minus 4 7 11.7 s. So minus 15 equal to, so s is going to be negative 15 divided by negative 11.74, which will be, comes out to be 1.27768, and more digits. We can write it as 1.28 meters up the slant height CD. It is instead given with a difference value of mu. The particle travels 1 meter up the track from the C before it comes to instantaneous rest. So it was like this, like this, like this, but this time mu is different and it comes to rest after 1 meters. Okay. Find the value of mu and the speed of particle at which instant it passes through C for the second time. So we will see that the speed here was 4 meters per second. V is 0. This is 1 meter, right? And we need to find mu. So what was our formula? Ma equal to, there was no applied force, so minus mu r, and there was minus its weight, so 10 m sine 30, right? So m got cancelled out. We'll do that later. Okay. So ma is equal to minus unknown mu, and r was 10 m cos 30 minus 10 and half will be 5 m. So we'll cancel m now. Okay. So the acceleration is unknown to us, but can we find by this one? Yes, v square equal to u square plus 2as. V is 0, u is 4, plus 2, acceleration is unknown, but s is 1 meter, right? 1 meter. So 2a. So this comes here, minus 16 equal to 2a. Yeah. So a becomes minus 8 meters per second square, which we'll use here. Minus 8 equal to minus mu 10 cos 30. 10 cos 30 is square root 3 over 2 minus 5. This cancels again. So this 5 will go there first. We cannot simplify this because it has mu. So minus 8 plus 5 equal to minus mu 5 square root 3. So this is minus 3 minus mu 5 square root 3. So mu comes out to be minus 3 divided by minus 5 square root 3, which is 0.3464, so we can say 0.346. 0.346, that is the value of mu if it has to reach 1 meter up and stop. But they're also asking us, and the speed of the particle at the instant that it reaches past C for the second time. So it goes up, stops, and comes back here. So they're asking what will be the velocity here. So we can again use the same v square equal to u square plus 2as. And now v square we want to find out in this case. U is 0, it's starting from rest to acceleration. Okay, acceleration will be negative 8 meter per second still, because still plus 2 times acceleration will be something and distance is 1 meter. Problem is the acceleration will not be same again, minus 8 meter per second square. No, we'll have to do it once more. Why? Because the 10 m sine 30, which was the mass, the weights component downwards, was resisting it earlier, which will be useful now. It will become applied force. So ma equal to applied force is this now. 5m will be become applied force, but resistive force will remain 5 square root 3, and mu is given to us 0.346. So 0.346 5 square root 3. I hope you understand, because when it is coming down, the friction will be backwards now. So it will still resist, but in opposite direction. However, the weight component will help it. So and m was there, right? It was m also. So m gone, gone, and gone. Acceleration comes out to be 5 minus 0.346 times 5 square root 3. Let me use my calculator for this. By the time I do this, I would request you to like this video by giving it a thumbs up, share this video with your friends, and subscribe to Math United. This will motivate me to make some more videos like this for you. Okay, what I'm getting here is 2, exactly 2. Acceleration is 2 meters per second, and that's what we will use here. So v square equal to 4. Yeah, so v equal to 2 meters per second. This will be the speed when it will be passing C for the second time, 2 meters per second.